My name's Naathan Mohan, and today I'll be sharing what I've been doing at the last 6 weeks at FSI, which is environmental concerns with fracking for natural gas. First off, I'd like to apologize about my voice. It's a little rough. I've been sick the last couple of days. And a little disclaimer, I didn't do any experiments because I can't afford an oil rig. So, just this is all metadata analysis. All right. So the current energy standpoint in the U.S. right now, most of the U.S.'s fuel supply comes from petroleum. So most of our energy as of 2009, it's 35%, and that number, it's staying pretty stagnant. It's projected by the EIA, which is an energy organization run by the government, that that number is going to stay stagnant for the next 20 years. Uh, Another number up there is the natural gas number. That number is about 23%. And that number is projected to rise for the U.S. because natural gas is a lot cleaner than petroleum engineering, and has about the same energy capacity, but it's cheaper and it's just a lot cheaper and it's just a lot cleaner to run. So as we make that transition, it's important to realize what goes into the extraction of natural gas, such as fracking. All right, so a brief introduction into natural gas. Primarily what it's used for now is to heat up houses. So those are costs that, like, I don't know, you'll see like hidden in your heating bill and stuff like that. You're not gonna go to like a gas station and be like, oh dang, the price of natural gas went up a buck or something like you would with petroleum. So it's most definitely not an evident source unless you're like paying house bills. So natural gas is on the rise though, and it may become a way we can run our cars or fuel our cars efficiently. All right, so I'll go more in depth into this. This is the basic extraction process for natural gas. There's multiple materials that natural gas can be taken out of. Uh, for example, in Saudi Arabia, there's sandstone, which if you drill down like 4 or 5 thousand feet, natural gas will just from the innate pressure of being 5,000 feet underground, natural gas will start coming out of that hole you just made. Uh, in Colorado, especially in the northeastern part where we live, this is not possible because there's this extremely dense rock called oil shale. So we resort to a method called fracking to get our natural gas out of the ground, which is basically we drill in about a little over a mile, 7,000 feet, 8,000 feet, and then we go across like at the 90-degree angle for about a mile, and then we just like send down a fracking fluid, and natural gas just magically comes up. But I'll explain this more in depth later. So areas of extraction, like I was saying before, this oil shale rock, while it's like super impermeable, nothing can get through it. It it contains a lot of oil in a ton of our oil supply. So it's definitely a usable. It's definitely not exactly sustainable because it's not good for the environment exactly, but it's something we can run our country off of. So to put a more local aspect type spin on things, I'd like to talk about the oil shale in our area. So in our area, there's a place called the Denver-Julesburg Basin, which extends from Colorado to Wyoming to like Kansas and Nebraska. And it's a large expanse of a place where we can extract natural gas from. And there's three main formations in this: the Lions Formation, the Wattenberg Field, and the Niobrara Shale. The Niobrara Shale is currently where we get most of our natural gas from. So the Niobrara Shale, it's fairly thick, and it's really it's super energy dense. My partner Justin will be talking about the Denver-Julesburg Basin and the Niobrara Shale more in depth later, but it's basically where we're getting a lot of our natural gas and a lot of our oil from. That's where Noble Energy does all its work to make its profit. So this is these are the initial mining steps. So first, you start off by getting a rig, a drill rig. So that's the thing in the left-hand corner over there, or Yeah, your left hand corner. So it's a huge piece of equipment that is attached via a steel cable, and you attach a drill bit to the end of that, which is on the right. So what that drill bit does is it just starts a borehole that goes through the ground. It can be about like 5 meters wide, or it can be a lot smaller than that, to like half a meter in diameter. But the borehole it'll just bore through the ground, and so about every 500 feet or so, a piece of steel tubing will slide down to the part that's been drilled out, and that piece of steel tubing will prevent any slip ups later on, so the natural gas can escape into the environment. And this process keeps continuing until we're 7,000 feet underground. Once you get to that 7,000 foot mark, the drill bit hits a concrete plug that's been poured down into that borehole. And so when it hits the concrete plug, it slowly starts turning to the right because it can't go through that plug. And then you get something that's called horizontal drilling. Now, horizontal drilling is fairly new. Noble Energy started doing it around 2006 to 2008. That's when they started like establishing the method, at least in the Niobrara Shale. And it's the way that you can go through across like a mile of shale. It increases the surface area of which you can extract natural gas from. So the next part of the fracking process is after this horizontal part of the well is drilled out, you either drop down explosives on a line, and then these explosives will sit in the horizontal part of the well, and then you can just blow them up with an electrical charge, and these will cause like several foot fractures inside the cementation, the steel tubes, and the rock. These can later be fracked. And then another method is something called like seats and balls. It's kind of hard to explain it without an appropriate graphic, but those balls in the right hand corner are basically put into something called seats, which are little humps inside the formation that are stuck on the tubes. So the ball will go and like sit in a hump, and then when the fracking fluid is pushed out, the ball will go through the hump, and the fracking fluid will push the ball like into that hump seat, and then create surface area to where natural gas can be fracked out of. So the actual fracking process itself, they just basically take hundred thousands of gallons of this fracking fluid and shoot it down into a hole. And so it's a pretty gelatinous fluid, which kind of surprised me. Fracking fluid is 95% water, 4% sand, and 1% other chemicals. So the 1% of the other chemicals makes a big difference. Lots of them are neurotoxins to humans, and many of them are harmful to the environment. So when the hole is fracked, the water and the sand basically widen the holes that have been cracked either mainly by the explosives, and then the natural gas, due to the innate pressure of being under that horizontal well, will start coming up over the next couple of days through that hole. Um, so to the environmental aspects of how the fracking affects the environment, one of the main problems is something called BTEX escape. BTEX stands for benzene, toluene, ethylbenzene, and xylene. These four chemicals are common in any sort of fossil fuel, whether it be coal, natural gas, or oil. So anyway, these four chemicals, one of them is a known carcinogen to humans. The three other ones are like they're suspected carcinogens. So when these escape into the environment, it's super bad for humans, especially in the large quantities in which it can. So one of the biggest ways they can affect us is getting into the groundwater and into the air. So, for example, if there's an underground aquifer, if the fracking doesn't go right, the benzene, toluene, ethylbenzene, and xylene, the BTEX chemicals, can go up into the aquifer. And especially if you don't have good treatment facilities in your town, or you're like in a rural area, which a lot of fracking happens there, and have an underground wellbore, this these chemicals can go up into the wellbore, and it can cause major problems. One of the biggest things, like there was a YouTube video, which I'll show you later, that like a woman was like lighting her faucet on fire or whatever, and then in the air, the chemicals are extremely volatile, which means they can go in the air and you can breathe them super bad. And there we go. This is the dude. He's gonna burn the stuff on fire, or the tap water. So that's like one of the bad effects of. God damn it. Um. Uh. That's one of the bad effects of the BTEX chemicals inside your water. But it's so it's definitely harmful if you drink that stuff. It's gonna hurt you. Um. So ways to prevent this is to have routine checkups of the pipeline. Well, the tubing that I was talking about before, when that tubing cracks, that's one of the easiest ways that BTEX particles can escape into the environment. So if those are regularly checked by the energy companies, hopefully they can prevent this sort of situation from happening. Um, Another problem is the failing of a borehole. The borehole can start collapsing on itself if there's a certain amount of capillary pressure inside the rock in which they've drilled, or paraffin wax, which is something we saw on our field visit, can come and like clog up the tubing in the borehole. So that can also be a problem. The thing with this is natural gas fracking is not going to go away. So if you look at the projected world numbers, it's it's going to increase by it's going to increase by a significant margin. It's close to a 50% increase in how much natural gas the world is going to use, and this is in trillions of cubic feet. So if we take the necessary precautions now, hopefully it won't affect the environment later. So in instead of preventative measures, there's also some amount of like there should be some way we can correct the BTEX particle escape. One big historical problem with this was the BP oil spill in 2009. If you guys remember, all the little birds couldn't get out of the water because their wings were full of oil. The microbes and bacteria are really good. Some of them are very good at processing these sort of chemicals so that they just dissolve into carbon dioxide. And this could be beneficial if these chemicals get into groundwater supplies. And so another form of filtration that we can use is something called active carbon filtration, which is basically charcoal that's been sent through an oxygen type of shot. So the oxygen causes a lot of little like pore holes in the charcoal, and so these are like absorption sites for the BTEX particles. So they get stuck in the charcoal and they can't escape into the environment. So I'd like to thank the FSI staff, Nick Orianopoulos, my mentor, and I'd like to thank my research and first company who sponsored me to be here, Noble Energy, the FSI program, and Nalcom, who let us go onto their drill rig sites and see how their chemicals worked with drilling rigs.